Welcome to the world of discrete electronics. Step into a realm where precision and creativity converge, where circuits come alive through individual components working in harmony. Discrete electronics is the art and science of crafting systems, using standalone elements like resistors, capacitors, diodes, inductors, and transistors. Let us build triple-mode tone generator. This circuit generates 3 different tones. You can use it as a call bell, burglar alarm, or any other security alarm. This circuit generates different musical notes, or tones based on the position of the rotary switch, S1. It uses a 555 timer IC1, in astable multivibrator configuration to produce the oscillating signal, which is then amplified and fed to a speaker, LS1, to produce the audible tones. 555 timer IC1. This versatile IC is configured as an astable multivibrator. It generates a continuous square wave signal whose frequency is determined by the values of resistors R1, R2, and capacitor C1. Rotary switch, S1. This 3-way switch allows you to select different values for resistor R2, effectively changing the frequency of the 555 timer and thus producing different tones. Resistors, R1, R2, R3, R4, R5. These resistors control the timing and amplitude of the 555 timer's output signal. Capacitor, C1. This capacitor determines the time constant of the 555 timer circuit, influencing the frequency of the generated signal. Transistor, T1. This transistor acts as an amplifier to boost the output signal from the 555 timer, enabling it to drive the speaker. Speaker, LS1. This component converts the electrical signal from the amplifier into audible sound waves. Let me explain how this circuit works. Astable multivibrator, the 555 timer is configured in astable mode, meaning it continuously oscillates between 2 stable states. The frequency of oscillation is determined by the values of R1, R2, and C1. Tone selection, the rotary switch, S1, selects different values for resistor R2. When the switch is in a different position, the timer's frequency changes, resulting in a different tone. Amplification, the 555 timer's output signal is fed to the base of the transistor, T1. The transistor amplifies this signal, providing enough current to drive the speaker. Sound production, the amplified signal is then fed to the speaker, which converts it into audible sound waves. The values of R1, R2, and C1 can be adjusted to generate a wider range of frequencies and tones. The circuit can be further enhanced by adding more switches or potentiometers to control the volume, tone, and other parameters. The circuit can be used to create various musical instruments, such as synthesizers and electronic organs. Stay tuned and keep learning. Subscribe to our YouTube channel www.codingscientist.com.